Here is something that still messes with my head. We built AI that can write code, pass the bar exam, beat grandmasters at chess, and hold a conversation that feels weirdly human. And yet, if you ask the smartest robot on the planet to reach into your wallet and pull out a single $5 bill, it would probably fumble, crush the leather, or grab 3 bills at once. That gap is the whole story of this video, and by the end of it, I think you will look at robotics differently. So do me a favor and hit subscribe now, because I am about to show you a tiny company in Shenzhen that might have quietly cracked the one problem everyone else has been losing sleep over. Stick around, this one is good. So let us start with that gap, because it is kind of strange once you sit with it. Modern AI is a monster in the digital world. It lives in text, images, numbers, and pure logic, and it is fantastic at all of them. But the physical world is a different beast. Picking up a coffee cup, folding a shirt, plugging in a cable, these are things a 4-year-old does without thinking, and they stay shockingly hard for machines. Researchers even have a name for this, Moravec's paradox. The idea that the stuff we find easy is hard for computers, and the stuff we find hard is easy. And nowhere does that bite harder than at the very end of a robot's arm, the hand. Here is my honest take up front. I think hands are the single most underrated piece of the entire humanoid robot race. Everyone is obsessed with the brain and the flashy backflips. Almost nobody outside the labs is talking about the fingers. But the fingers are where the dream actually lives or dies. Let me explain why hands are such a nightmare to build. A human hand has around 27 degrees of freedom. That is 27 separate ways it can bend, twist, and move, all packed with sensors, muscles, and tendons in a compact, self-healing package that also happens to survive you slamming it in a car door. Now try building that out of metal and plastic. You basically have 2 ways to do it. Option 1 is tendon-driven, where you put the motors up in the forearm and run cables down to the fingers. Sort of like how our own tendons work. It looks elegant, but it is a calibration headache. Cables stretch, they wear, they snap, and the gap between simulation and real life gets messy fast. Option 2 is direct drive, where you cram tiny motors right into the fingers themselves. That is much harder to engineer, but when you pull it off, every finger basically becomes its own little robot, and the whole thing gets way more predictable. Hold that thought. So who is actually building these things? The state of the art is a lot more fragile than the hype suggests. Start with Tesla and Optimus. Elon has hyped the Gen 3 hand hard, and on paper it sounds incredible. But here is what bugs me. We still have not seen a clean, live, unedited demo of Optimus reliably manipulating random objects the way a person does. Lots of polished videos and promises, not a lot of raw. It just works footage. And when a company is that secretive about one capability, my gut says it is not solved yet. Then there is Boston Dynamics and the new Electric Atlas. I love these guys. They are the best in the world at making robots move, but their hands are deliberately simple. Atlas is built for heavy industrial work, so they went with rugged, reliable grippers over delicate fingers. Smart trade for a factory floor, useless for pulling a bill out of your wallet. Figure is probably the most impressive of the American pack. The Figure 03 has 16 degrees of freedom per hand. It runs on their Helix AI model, and it is already doing real work on the BMW line in Spartanburg, where it has helped build tens of thousands of vehicles. But here is the dirty little secret of this whole industry. Hands are the part that wears out first. When you run these robots hard, shift after shift, the fingers take the beating, and swapping out worn hands becomes a constant, expensive chore. Durability is quietly one of the biggest blockers nobody wants to put on a keynote slide. And then, the wave of Chinese humanoids. A lot of them, to keep the price down, ship with a basic 6 degree of freedom gripper. And the most common one is the Inspire RH56. It is a solid, affordable workhorse, and it is everywhere. But 6 degrees of freedom means coarse actions only. It is a mitten compared to a real hand. Fine assembly, in-hand manipulation, delicate stuff. Forget about it. So where is the gold standard? That would be the Shadow Hand out of the UK. A beautiful, tendon-driven marvel with 24 movements that researchers have drooled over for years. The problem? It costs north of $100,000, and some setups push closer to $300,000. It is also famously delicate, so it stays in the lab, behind glass. Basically a Ferrari you are too scared to drive. See the pattern here? The cheap hands are dumb, the smart hands are fragile and unaffordable. That is the wall the entire field has been slamming into for years. Which brings me to my favorite part. At ICRA 2026 in Vienna, one of the biggest robotics conferences in the world, one of the most talked about things on the floor was not some giant humanoid. It was a hand sitting at booth 121 from a company called Wuji Technology. Here is the backstory I love. Wuji got started back in 2019, and they did not begin with hands at all. They started life as a motor company, backed by their parent Pan Motor, grinding away at high-torque density electric motors, boring foundational work, and that turned out to be their secret weapon. If you get really good at making tiny, powerful motors, you can do the one hard thing everyone else avoids. You put the motors directly inside the fingers, and that is exactly what they did. The Wuji Hand 2 is a fully direct drive, biomimetic hand with 20 active degrees of freedom, 4 independent joints in every single finger, and a thumb that properly opposes like a real one. No tendons to stretch or snap. Every joint runs at a 1000 Hz control rate, and they built in a proper thermal design so it can keep working for long stretches without cooking itself. Now here are the numbers that made me sit up. The original Wuji Hand comes in under 600 grams, and the second generation pushes that toward half a kilo, roughly the weight of the phone in your hand. It delivers around 15 newtons of force per fingertip, and it is rated for over 300,000 grasp cycles, with internal testing past 1 million. Durable, light, and then the price is the real kicker. The first Wuji Hand sold for around $5,000. Compare that to $100,000 and up for a Shadow Hand. That is not an improvement, that is a different universe. But here is the part that made me go, oh, these people actually get it. The hand is only half the story. The other half is a glove. Because the real bottleneck in robotics right now is not brains, and it is not even bodies. It is data. AI models learn from mountains of examples, and for text and images, we basically have the whole internet. But for physical manipulation, for the precise feel of your fingers rolling a screw or peeling a sticker, that data barely exists. Nobody ever recorded it, and you cannot just download it. So Wuji built a data glove to capture it. Their glove tracks your hand with over 500 touch points and streams tactile and pose data at 120 frames per second. You wear it, you do a task with your own hands, and the system records exactly what your fingers did and felt. That data can then train an AI model, and because the glove captures the motion in a general way, the learning is not locked to one specific robot. The term for it is embodiment agnostic, which is a fancy way of saying the lessons transfer across different hands and robots. This is the master key. It is not just that Wuji built a cheap, tough, dexterous hand. It is that they also built the tool that generates the exact kind of training data the top embodied AI labs, the Google DeepMinds and physical intelligences of the world, are starving for. The hand does the manipulating. The glove feeds the brain. Together, they go straight at the data problem, holding the whole field back. Why I think this changes the whole race. So here is where I land on all of this, and then I want to hear what you think. For the last few years, the humanoid robot race has been framed as a battle of brains and bodies. Who has the smartest model? Who can do the coolest backflip? But I think that framing is about to flip. The bottleneck was never really intelligence, and it was never strength. It was the 10 fingers at the end of the arm, and the lack of good data to teach them. Whoever solves hands cheaply and at scale unlocks everything else. And that is why a scrappy motor company from Shenzhen showing up in Vienna with a $5,000 hand and a sensor glove might end up mattering more than another glossy humanoid reveal. Not because they are the biggest name in the room, but because they are aiming straight at the actual lock instead of the shiny door. If the next few years come down to who has the best manipulation and the best data, and I think they will, moves like this could pull the whole 2030 humanoid timeline forward. Anyway, that is my read, and I am pretty bullish on it. If you got something out of this, do me a solid and smash that like button. It really does help this video reach more people who nerd out about this stuff. And if you are not subscribed yet, come on. You made it all the way to the end, so hit subscribe so you do not miss the next one. Trust me, the hand wars are only just getting started. I will catch you in the next one.